Welcome to all of you in my YouTube channel Physics Cafe by Manjeet Kaur. In today's video, we will study about constraint and its types. Our first type is holonomic and non-holonomic constraint. Our second type is rehonomous and scleronomous constraint. So first, we will discuss its definition. So what are constraints? So constraints are the condition that limit the motion of the system of particle. That means if we have a number of particles in a system, the particles are moved in the system. So who control them? So constraints are the condition that control the movement of the particles. Here we take an example. This is a gas cylinder in which number of particles are moved. Have you ever think why the number of particles move only inside the container? Why they come outside the walls of the container? Who restrict them to come out from this container? So our answer is constraints. Constraints are the condition that limit the movement of the particles of the gas molecules. That means gas molecules in this container are constrained by the walls of the container to move inside the container. That means गैस मोलिक्यूल्स को इसके अंदर ही घूमना है। जो कौन तय करता है? कंस्ट्रेंट्स जो उस पर अप्लाई होती हैं, इसकी वजह से जो नंबर ऑफ पार्टिकल्स है वो कंटेनर की वॉल्स के अंदर ही मूव करते हैं और इससे बाहर नहीं आते। सो फर्स्ट वी राइट इट्स डेफिनेशन। कंस्ट्रेंट्स are the conditions that limit the motion of the system of the particles. That means that condition which control the movement of particles is called constraint. Example: this is any space which have number of particles are moved inside this. This is particle 1, particle 2, particle 3 and so on. So distance between them is noted by C1 and distance between them is noted by C2. So we can write this is our rigid body. In rigid body, the distance between the two particles remain constant. That means this is our system in which we have a particle 1, particle 2 and the distance between them is C1 which is constant. And similarly for particle 2 and particle 3, the distance between them is noted by C2 which is also constant. So we can write the Rij is the distance between ith and the jth particle. That means Rij is equals to Ri minus Rj is equals to Cij. That means Rij is the distance between the ith and jth particle, which is equals to Ri minus Rj, which is equals to Cij. So we can write Rij minus Cij is equals to 0. We can also write Rij square, square of Rij square minus Cij square is equals to 0. So this is the equation of constraint for rigid body. This is our example. This is our system. But we said Rij is the distance between the two particles, which remains constant. So we can take Ri minus Rj, which is equals to Cij. So we can write Rij minus Cij equals to 0. Here we taken square. So this is the equation of constraint for a rigid body. Now we can write its types, classification of constraint. As we said, constraints are of two types. First is holonomic and non-holonomic, and second is holonomous and scleronomous constraint. So first we write its types: holonomic and non-holonomic constraints. And second is holonomous and scleronomous constraints. So first we write the definition of holonomic and non-holonomic constraints. So let's start. We have holonomic constraints and non-holonomic constraint. So holonomic constraints are those constraints which we express as the equations connecting the number of coordinates. That means if we have a system in which number of coordinates are acted on that constraint are the holonomic and non-holonomic constraints. So we can write if the constraints can be expressed as the equation connecting the coordinates are that means in a system number of coordinates are acted on that constraint is a holonomic constraint, which we define as this is our function which r1, r2, r3 and so on is rn, and this is our t function of t. This is have here we have function of position and this is function of time is equals to 0. Then these coordinates are holonomic constraints. Means if we have the number of coordinates which are expressed as the constraints are the holonomic constraints, which have a function of position and time which is equals to 0, and these coordinates are holonomic constraints. Now next is if the constraints cannot be expressed in this manner as we discussed in holonomic constraint, in this manner are called non-holonomic constraints. That means holonomic constraint. Those constraints which cannot be expressed as a function of position and time are called non-holonomic constraint. So we can easily see the difference between holonomic and non-holonomic. In holonomic, we can take the number of coordinates in the equation and then constraints are acted on this, and non-holonomic we cannot express the number of coordinates like this. So those are non-holonomic constraints. Our next is now we have to write its second type, which is Hieronymus and Scleronomous constraints. So we can write Hieronymus constraints and Scleronomous constraints. In a Hieronymus constraint, we have equation which the equation of constraint is clearly function of time. So that equation is Hieronymus constraint. That constraint are Hieronymus constraint. And in Scleronomous constraint, the equation of the constraint is not clearly the function of time. So that is Scleronomous constraint. So we can write first the definition of Hieronymus constraint. If the equation of constraint is an explicit function of time, then it is Hieronymus constraint. That means those equations of constraint which is clearly function of time, is called Holonomic constraint. And now we have to write Holonomic constraint. If the equation of constraints is not explicit function of time is called function of time, then it is scleronomous constraint. So we can clearly see the difference between these both these constraints. First is Holonomic, in which we have a clearly function of time in the equation of constraint, and in scleronomous we have not explicit function of time in the equation of constraint. We also take its example. If we have a bead sliding on the moving wire is example of Holonomic constraint, and a bead sliding on the rigid fixed wire is an example of scleronomous constraint. When constraints are acted on the system of particles, then the coordinates are no longer independent. Then those coordinates are connected to the equation of constraint and become dependent on each other. From above, we have a result. When constraints are imposed on the system of particles, then the coordinates which are involved in the system of particles are no longer means independent. That means they became dependent on each other because of the equation of constraints, because those coordinates are connected to each other. This is our diagram in which this is x-axis, this is y-axis, and we have a number of particles in this system. This is particle 1, this is particle 2, and this is particle n number of particles, and the particle has mass and its position vector is r1, and this particle r2 whose position vector is r2, and the difference between r1 to r2 is noted by r1 minus r2, and the position vector of nth particle is rn, and this is our ith particle. So this is basically our system which have number of particles are moved in this. So in this system, when we apply constraints on this number of particles, then the coordinates which are Ri are no longer mean independent. Those coordinates are because those coordinates are connected to each other by the equation of constraint and became dependent on each other. So we can write when constraints are imposed on the system of particles, on the system of particles, then the coordinates which is Ri, it is the position vector, and the coordinates which is Ri are no longer independent. That means they become dependent on each other. Those coordinates those coordinates are connected are connected to each other by the equation of constraint to each other by the equation of constraint and became by the equation of constraint and became dependent on each other and became dependent on each other. So what we said, if we have a system, then we apply constraint, then the number of coordinates which are involved in the system not not dependent on each other. They they are no longer remain independent. They depended upon each other because of the equation of constraint. So this is our total topic of constraint, in which first we write its definition, then we explain its types. So we revise all once again. So what are constraints? Constraints are the condition that limit the motion of the system of particles. That means who control the system of the particles which are involved in that are called constraints. Example, this is our rigid body, this is particle 1, this is particle 2, and the distance between the two particles remains constant, which is denoted by C1, and the distance between particle 2 and 3 is denoted by C2, which is again constant. So Rij is the distance between the ith and jth particle. So we can write Ri minus Rj is equals to Cij. So we can write Rij minus Cij equals to 0. When we square this, Ri square Rij square minus Cij square is equals to 0. So this is the equation of constraint for rigid body. Now we have its classification. First is holonomic and non-holonomic constraint, and second is renomous and scleronomous constraint. In holonomic constraint, we have if the constraints can be expressed as the equation connecting the coordinates are. That means in those constraints, when we define the function of coordinates which are involved in that is called holonomic constraint, and non-holonomic constraints are those if the constraint cannot be expressed in this manner. That means in this manner, those functions, those equations which we cannot define like this are called non-holonomic constraint. And next is renomous constraint and scleronomous constraint. Renomous constraints, if the equations of constraint is an explicit function of time, is called renomous constraint. That means those equation of constraint which is dependent upon time are called renomous, and in scleronomous, if the equation of constraint is not explicit function of time, that means they are independent function of time, that means they are not dependent upon time, or called scleronomous constraint. and this is our system xy plane in which number of particles are moved. This is particle 1, this is particle 2, and this is n number of particle. So particle 1 has a mass and its position vector is r1, and particle 2's position vector is r2. So the distance between is denoted by ri minus r2 is equals to cij, which we write first, which is constant difference between them, constant distance between them, and this is the position vector of n particle, which is rn. This is our ith particle. So when constraints are imposed in the system of particles, then the coordinates, which is ri, r1, r2, rn, so on, are no longer independent. That means वो independent काफ़ी समय, एक समय आने तक वो independent नहीं रहते हैं. They depended upon each other. Those coordinates are connected to each other because by the equation of constraint and became dependent upon each other. Because of the equation of constraint, they are no longer independent upon each other. So this is our today's topic, constraint and its types. I hope I clear your all doubts. Thank you.